Nearly everything we do is driven by code. Every line you write, or don't write, makes a difference. The choice is yours.
Hi everyone, my name is Josh Long. I'm a Spring developer advocate on the Spring team, a Kotlin Google developer expert, a Java champion, and more than anything, I love production. Today, for many people, the cloud is production. A big part of the movement of software to production, of course, is building software that works well in that environment. And in this video, we're going to take a look at how to build cloud-native services using Spring Boot and Spring Cloud. There are a ton of things to investigate, so let's begin. In this section, before revisiting some of the patterns that allow us to build cloud-native applications, let's revisit some of the features in Spring Boot and see why it has cemented its position as the #1 most useful technology for building applications destined for the cloud. We're going to go to start.spring.io and we're going to build a new application. And I'm just going to call this Bootiful Kates, right, for Kubernetes. And we're just going to bring in, I suppose, a reactive web endpoint and the Spring Boot actuator. And that's it. That's all I really care about at this point, I suppose. So I'm going to go ahead and hit generate, and it doesn't really all that much matter what version of Java I chose. The latest and greatest will work just fine. Java 11 is the current long-term supported version. Java 8, of course, is supported for reasons. So there's all that, and you can use any one of them. It doesn't matter. And what we're going to do is we're going to go to our downloads directory, and we're going to build a new application. We're just going to open this application up in our IDE. So here we are, demo.zip. We have a brand new application, and what we're going to do is see that this application is ready to go to production in a cloud platform. Actually, that's actually part of the API, is this idea of a cloud platform. So what I mean by that is that you can actually decorate beans that should be only run in a particular cloud platform. I can say, okay, for example, that this bean should only exist, or should only run conditionally if it's detected that we're running inside of a cloud platform like Kubernetes, right? And so here I can say, okay, well, this is a Spring initializing bean, but it's only going to run, again, when the platform thinks, when the framework thinks that we're running inside of Kubernetes. Now, of course, you can force it to think as much. You can actually change properties here in the application properties file. So you can say Spring main cloud platform equals Kubernetes. Run this code. Right, and there's hello Kate. Now, if I comment this out so that it doesn't think that we're in that platform, and then just restart it, it doesn't print out hello Kate. Now, this is useful. Of course, obviously, when we run an application in production, we want to turn it into a container, right? We're going to want to run it in a Docker image or an OCI image. So what I'm going to do is I'm going to remove that conditional on annotation, because we're just going to look at regular Docker here. And we're going to turn this into a container. We have now a simple application, and we're going to use the class name to just sort of distinguish it. Hello containers from. Okay. And the other thing I want to do is I want to change the name. I gave it the name demo, but the thing that we're going to do here will actually create a Docker image for us, and we want to make sure that we don't clash with anything else in my Docker images. So I'm going to use this artifact ID of Bootiful Kates. With that done, I want to now turn my application into a Docker image. And the same Docker image I could then deploy to a cloud platform. There's a lot of different technologies that we could use to turn our application into a Docker image. One thing that we've found to be very productive is a thing called a build pack. Now, this build pack idea borrows from the Cloud Foundry and Heroku ecosystems. It's this idea that we can give it an application artifact, and it turns it into a container that we can then deploy. I'm going to do Maven clean Spring Boot build image, and that's actually going to build the application and turn it into a container by passing the jar through a Java build pack, which will then create a sensible file system that has everything that's required to run this application. And this is actually using a Cloud Native Computing Foundation project called Paketo. There's a lot of concerns that go into running an application in production, things like security, things like memory, etc. But all of that is sensibly addressed here. There's overrides, there's hooks, there's environment variables you can specify, things like that that are part of Paketo. But for the common 80% case, you're going to find that this is more than enough. So now if I go to Docker images, there it is. There's our application. So there's the application that we want to run. This is a Docker image ID. I can say Docker. So the application has started up, and there's hello containers from common example demo Bootiful Kits application. So now we have something that we can take into Kubernetes and to other cloud platforms like Cloud Foundry, or anything really that takes a Docker image, Docker Compose, if people use that, Mesos, whatever. We are already off to the races, right? This is, of course, just the beginning. There's a ton more support in Spring Boot for building Kubernetes-ready applications. We've only just begun to cover the support here. We've looked at basic build pack-centric Docker containers or OCI image container generation through the Spring Boot Maven plugin, which is, by the way, also available through Gradle, first of all. And second of all, you can customize in almost infinite variety the generation of the layers in the OCI image from within the plugin. That's the first thing. Second thing is there are other things that we could look at beyond our limited time today. For example, we could look at things like using the actuator to create Kubernetes liveliness and readiness probe endpoints. We could also look at graceful shutdown, a feature that stops any incoming requests and gives the application some time to allow any in-flight transactions to complete before the container shuts down. In this section, we're going to need a couple of sample services. So I've built two different services, one called an order service and one called a customer service. You can see that the first endpoint creates orders given a customer ID. And here, there's no actual orders. I'm not even bothering with the database. I'm just creating a very simple randomized sort of list of records given a customer ID. For the customer service, I'm pre-building a randomized list of customers using random names from a list of pre-configured names. So the endpoint just returns the list of customers as a reactive stream. So I've got these two services. I want them to both be able to participate in service registration and discovery. This is important for what we're going to be doing. So I have elected, when I built them, to include the Spring Cloud Netflix Eureka Discovery Client. Spring Cloud has the ability to talk to a service registry. We can talk to a number of different service registries. I'm using Netflix Eureka, but you could also use Apache Zookeeper, HashiCorp Console, Kubernetes and Cloud Foundry itself, and a number of others. We need to stand up an instance of our service registry in order to do the work. I'm going to go to start.spring.io and I'll create a new Eureka service, right? This is a very nice thing to be able to do, particularly for a demo, but you could use anything, right? You don't have to stand up your service registry with start.spring.io. It just happens to be very convenient. Here's my new Eureka application. I need to do two things. I need to say enable Eureka server, and then in the configuration, I need to specify just the bare minimum. It's up and running, and I can confirm as much by going to the browser, 8761. And there I can see that there are no instances yet registered with this service. So I need to now restart my order service and my customer service. Okay, there they both are. Now I want to talk to both of these. I want to build an API gateway. We're going to use a project called Spring Cloud Gateway, and we want it to also talk to the service registry, Eureka. I'm going to call this Gateway Service, and I'll hit Generate. Spring Cloud Gateway is meant to be a proxy. You define routes that accept incoming requests and then act on those requests before sending them on to their final destination. We can use the route locator builder to define the routes that our system cares about. We're going to use different route specifications. We're going to say that we expect to match incoming requests destined for /proxy, and that we expect those routes to then be forwarded to our downstream service. We could use an absolute host and port. we can use this LB prefix to tell the service to load balance the request by calling the downstream service. Obviously, we have a problem. The incoming request will be proxy, but the downstream service, customer service, doesn't have a path called proxy. So we need to remove the path from the incoming request and set it to be something that exists on the target service, like so. Just for fun, I want to also add a custom header. You see, these filters are where you get a lot of the power out of Spring Cloud Gateway. So we can say, add that. Now, if I deploy this, now we can see that it's working by going to localhost proxy, and it makes a call to the downstream customer service as though it was running on this host and port, when clearly it's not. Spring Cloud Gateway can do all sorts of interesting things. You can also use configuration to dynamically define the routes as property files or YAML files. Those can be version controlled in the Spring Cloud config server. You can dynamically refresh those configuration files. So there's a lot of interesting opportunities. One of the more useful things you might do without any code whatsoever is just to have the locator. And the locator automatically sets up routes for you. I did this the hard way. I used /proxy as the prefix. But now, with this locator, I can go to localhost 8080 /customer-service /customers and make the same exact request without any Java code whatsoever, or at least without any extra Java code whatsoever. The next kind of service that we care about is a reactive API adapter. We're going to build a new module called client, and we'll use the reactive web support. We're going to use Lombok, and of course we want to register ourselves with the service registry so that we can read information from the service registry. Let's open this up in our IDE. In order to do our work, we need the order and customer DTO from each project. So let's go copy and paste those. With these two types in our code base, we can now build a client to talk to that downstream service. In order to do that, we're going to need a reactive web client. This is a non-blocking HTTP client that we can use to make HTTP calls to the downstream services. Let's build the client. Now I want to make a call to the downstream service, and here too, I want to take advantage of the load balancing possibilities offered by having the service registry. I can do this by injecting a reactive load balancer filter, and then configuring that on my web client. So now I can just say HTTP customer-service customers. The host will be swapped out. The service ID will be swapped out and replaced with an actual host. I'll retrieve the data, and I'll say that I expect the data to be coerced into a JSON stream, a reactive stream of type customer. Okay, so there we go. There's my entire client. First, let's create a runner to demonstrate their use. Okay, suppose I want to make a call to the client. I say client.give me the customers, and now I've got a reactive stream of customers. Well, what happens if something should fail? There are nice operators that I can use, like for example, retry, or retry 10 times, or retry 10 times and then use a backoff. I can do things like that to make my services more reliable. I can also specify timeouts. I can say timeout duration dot of seconds. I can also specify that when something goes wrong, I want to degrade gracefully by using an exception handler. So here, I'm given a chance, given an exception, I'm given a chance to return some other stream besides the one that would have been returned otherwise. So this is one way that reactive APIs allow us to build more reliable services. Another really nice thing about reactive APIs is that if this isn't enough, it's easy to add things without changing the API because, again, every type we're dealing with is just a publisher. There's a nice third-party project called Resilience for J, which gives you the ability to easily add things like bulkheads, rate limiters, retries, and circuit breakers. I'm satisfied, however, for now that we've done enough to make our services more reliable. Let's talk about one of the other big benefits of using reactive APIs, namely the ability to do really seamless scatter-gather kinds of composition. So what I'll do is I'll say customers.flatmap, and then for each customer, I want to zip two streams. I want to create one stream out of the customer and another one out of the orders. So I'll say flux.zip, and the first operand, the left side of the zip, will be mono.just C, and the second will be client.getOrders for customer C.getID. And this gives me almost everything that I want, but what I really want to do is I want to collect all of the orders into a list. So now, if I return this, what I get is a tuple containing the customer and that customer's orders. Now again, these are all references to types that will eventually give me these things. Nothing has been resolved yet, right? If I run this code up until this point, nothing will have happened. I need to subscribe, so this gives us chances to rewire the stream. What I want to do now is aggregate these things into an aggregate type. So I'll create a new one here for my client view called customer orders. Data and required args constructor are in place. Now I can say tuple to flux.map tuple new customer orders tpl.getT1 customer tpl.getT2. There we go. This is my stream of customer orders. Now I can visit each one. Before I can run this, I need to make sure I configure a service ID so I can register with the service registry. Spring.application.name equals client. And I also want to make sure that I disable ribbon. I want to use the Spring Cloud load balancer abstraction instead. There we go. There's our data. We got our custom orders, each of which contains a customer, and each of which contains one or more customer orders, with the customer ID pointing to the same ID as the customer. And there we have it, my friends. We've looked at a lot of different things today, but we're just about out of time. Unfortunately, we've only just begun to scratch the surface, obviously, but we are just about out of time. Now, obviously, there's so much more that we could have covered, so much more that we could have seen. We could have, for example, taken a look at how to build memory-efficient GraalVM AOT, or ahead-of-time compilation native images using Spring GraalVM's native support. We could do that easily. You just add a dependency and configure the Spring Boot Maven plugin, and voila, native image for whole categories of applications based on Spring Boot. That feature works in hand with the build packs feature, which we've already seen today. So you can actually just slightly modify that configuration, and instead of having a Docker image with your .jar based application, you'll have a native image in there, right? An ahead of time compiled native image inside of your Docker image, ready and raring to go for production in a cloud environment. We could have looked at that, but we're just about out of time. We could have looked at other patterns like centralized configuration with Spring Cloud Config and the Spring Cloud Config server, HashiCorp Vault, and the various integrations from various cloud platforms supporting configuration like Azure's config support. We could have, but we're just about out of time. We could have looked at config maps inside of Spring Boot 2.4, the native support for Kubernetes config maps in Spring Boot 2.4. But again, we're just about out of time. We could have looked at how to do easy messaging and integration with Apache Kafka, RabbitMQ, and Spring Cloud Stream. But again, we're just we're just about out of time. We could have looked at how to do distributed tracing with Spring Cloud Sleuth and Zipkin. We could have looked at using tools like Prometheus and Wavefront along with Micrometer to better support observability. We could have done that, but again, we're just about out of time. We could have looked at, had we more time, how to do distributed locks with Spring integration to prevent multiple discrete actors in a system from acting on the same resource, if we had more time. We could have looked at, had we more time, how to use platforms like Azure Spring Cloud, a managed platform as a service-like environment running on and furnished by the Spring team and by Microsoft Azure, to have push-button simple deployments of Spring Boot-based applications to a production environment. We could have also, in that same vein, looked at using platform-specific infrastructure through the various integration projects supporting, among other things, Microsoft Azure, Google Cloud, Alibaba Cloud, and AWS. Want to use Alibaba Sentinel with Spring Cloud? You can. Want to use Azure Cosmos DB with Spring Boot? You can. Want to use AWS's S3 with Spring Boot? You can. Want to use Google Cloud Spanner with Spring Boot? You can. But I'm afraid, my friends, we're just about out of time. So I want to thank you so much for your time today. I appreciate everything. I hope you enjoy, and I hope you have a great show.
Code is everywhere. You get up with it in the morning. You take it with you on the go. It brings us closer to one another. It makes life easier, nicer, and it allows you to discover the world, make new connections, realize ambitions. It may even save your life. Nearly everything we do is driven by code. Every line you write, or don't write, makes a difference. That's why we write code that contributes to a better world, that helps shape a sustainable food chain, that empowers people to become financially self-sufficient and gives people back control of their data. Whatever you dedicate your talent to, or don't, makes a difference. The choice is yours. What difference will you make?